Hello, everyone, and welcome to another episode of Code and the Coding Coders Who Code It. I'm your host, Drew Bragg, and I'm joined today by the one and only Kevin Newton. Kevin, for those who are unfamiliar with you, why don't you introduce yourself?
Hey, thanks for having me. I'm Kevin Newton. I work at Shopify on the Ruby and Rails infrastructure team. You may have seen me on the internet working on things like Prettier or Syntax Tree or YJIT, and more recently, the new Ruby parser.
So for those of you who are unfamiliar with the show, the way this is going to work is I'm going to ask Kevin 3 questions. What are you working on? What blockers do you have if you don't have a current blocker? What blocker did you recently have and how'd you solve it? And then at the end, I'm going to ask Kevin to share something cool, new, interesting that he's learned or discovered. And it doesn't even have to be coding related. Kevin, I know this is a loaded question for you, but what are you working on?
So I work on a team at Shopify, the Ruby and Rails infrastructure team. It's pretty broad. There are a bunch of sub teams within it. There's a team working on Truffle Ruby. There's a team working on Ruby dependency infrastructure. My sub team of that is the C Ruby team. We work on features for C Ruby, making it better, making it faster, making it more efficient. And then the sub team that is the Ruby parser team, which is really me. It's just me. I pair with people a lot, which is nice because there are a lot of intelligent people that I get to work with. But for the most part, I'm working on this project. The goal of the project is to rewrite the Ruby parser for a lot of reasons. One of which is just it's never really been done. It's the same parser it's been since the very beginning of Ruby. It's evolved over time, but it's never been rewritten. But there's a lot of pain in the ecosystem dealing with keeping up with parser changes because you can only use the C Ruby parser within C Ruby. You can't use it in other projects. So projects like Truffle Ruby, JRuby, Sorbet, RubyCop, they all have to use their own parsers and they all have to be maintained. So the goal of this project is to alleviate that pain, make it so that everyone can use the same parser, make it so that the parser is fast, efficient, can recover from syntax errors so that you can use it in an IDE more effectively, and make it maintainable, well-documented, easy to understand and approach, and hopefully make it a significant improvement.
That sounds like a heck of an undertaking. I guess the simplest, most basic question I have to start is, what is that going to be written in?
A lot of languages were discussed. Ruby itself was discussed. A lot of people have a lot of different feelings on this. This is called bootstrapping a language, right? Is when the entire language is written in that language. And in my opinion, it works better in compiled languages because in interpreted languages, in order to have the parser be written in Ruby, you wouldn't be able to use the parser to parse the parser. So the only way to do that would be to ship the bytecode representation of the parser. So it's like it's already parsed into bytecode. You have to ship the bytecode to then build the parser, to then use the parser to parse everything else.
Okay.
The other concern is GC pressure, like you're going to allocate a lot of objects in a parser. Is it going to become too slow? So Ruby was advocated for as an option, but in the end, it's like there's a lot of challenges that go into it. This is already a tough enough project. Let's not go and tackle all of those as well.
Sure.
So that was one. Another one was Rust or Zig. These are the hotness, the zeitgeist, if you will.
The YJIT project was just rewritten in, or is actively being rewritten in Rust. Is that done or
was rewritten? Yeah. So that's in Rust. So yeah, Rust is a compelling option. There's a lot of reasons why YJIT was able to do Rust. One of them is that YJIT is optional. YJIT is only added into Ruby if you are on specific systems. It used to only be x86 machines. Now we support ARM64 as well. So there's 2 different computer architectures. YJIT is not going to ever support every single system that Ruby supports. So Ruby can be compiled and run on toasters. I mean, really, Ruby can be compiled and run on a wide variety of targets because it almost runs on anywhere where you have a C compiler.
Sure.
So Rust C does not target every single place that GCC does. I think they'll probably catch up at some point, but it's also just not really feasible to rewrite the entire project in Rust. As much as the internet and hacker news would love to tell you, not everything should be rewritten in Rust. There's a lot of things that C Ruby does that aren't necessarily up to the borrow checkers standard. Anyway, so the parser is different from YJIT because the parser is not optional. YJIT is an optional module that's added on. The parser is going to be used for every single program that Ruby ever runs. It has to run on every single platform that Ruby runs on. So one of the considerations is targeting. And I don't know if that would necessarily be the only reason. The other thing is the entire Ruby code base is like a 25-year-old code base, and it's maintained by very experienced C programmers. To me, it makes no sense to go and say, okay, let's go rewrite this fundamental piece of the architecture in a completely different language that none of y'all are like super familiar with. And even if they are, even if one or two of them are like very good at Rust, which I'm sure there are some, a couple of my coworkers that work on YJIT, obviously they're more experienced in Rust and they are also C Ruby contributors. So clearly there are people that can do it, but like not everyone is. And like, why waste all that talent? So Rust is an option. Zig was considered as an option. It's like more of the hotness. It's another systems level language that links really well with C. Actually, in my opinion, links more easily with C than Rust does. But in the end, why not just write it in C?
Sure.
The whole code base exists in C at the moment. It's going to be much easier for the maintainers who are going to have to maintain it to go and like carry it on. So why not just do it in C? So the answer to your question, the very long-winded answer to your question, it's going to be written in C.
No, I think that was a great answer and a great explanation because you're right. Like Rust is the new hotness. I see it everywhere. So why wouldn't it be written in Rust? I think that's a great explanation to have. And then also, why is it not written in Ruby? I love Ruby. I know it's not perfect for everything. So it's going to be written in C, which is what the parser's already written in?
Yes.
Okay, so C, but this will now be compatible with things like JRuby, Truffle Ruby.
Yeah, so that's one of the two main differences. The first is that the current parser uses a lot of C Ruby internals. So it will use hashes, it will use arrays, it will use structures that are inherent to C Ruby. And you can't separate the two. So Truffle Ruby, JRuby, Sorbet, they don't have these structures. They don't have them. So they can't use that parser. So the first thing I'm doing is, as part of this rewrite, is like not linking against anything internal to Ruby. This is a separate project. So the end result should be, if I do this correctly, that it will be in the C Ruby code base, but it will generate a separate shared object file that can be linked from other projects that will be distinct and won't require any Ruby headers. We will link it directly into C Ruby as part of the build, but this will also be a separate artifact that'll be created as part of the build that people can then go pull in.
Okay. Wow. Just hearing the somewhat simple explanation of it just makes it sound like a lot of work.
I actually don't want it to sound like that. I mean, it is a lot of work, but it should be a better situation going forward, and it should make it much more approachable. The initial work of getting it off the ground is a huge pain.
Yeah.
But making changes going forward, it's going to be, I mean, magical unicorn rainbow land. It's going to be wonderful because you're going to make minimal changes to the parser, and then every project in the ecosystem is going to benefit.
Right. And because right now, every basically JRuby, Truffle Ruby, all the other implementations of Ruby need their own parser because they're not compatible with the one that we have.
Yes.
So you'll essentially, everybody who is spending time and effort on their own parser could just turn that time and effort into this parser and just make it that much better for the entire Ruby ecosystem instead of theirs.
Or they could just leave that to the core members and then just go work on their actual project.
Sure.
The thing is, like, writing parsers is not the fun part of writing a language.
Right.
It's the least fun part, in fact.
But yet it's so important.
It's so important. But over the years, there have been so many different approaches to parsers. So many different approaches. It's an academic pursuit. Everyone loves to talk about it in academia because it's like tangible. It's like you have this text, you want to transform it into a structure that you understand. What do you do? So it's like there's so many approaches. There's so many years of history of this thing. So many different opinions on what the right way to do it is. And at the end of the day, it just doesn't matter. You just want the dang result.
Right. And this will be a huge step, I think, in improving Ruby tooling.
Yeah.
Something that, as much as I love Ruby and the community, I think our tooling is improving, but it's lacking. I think that's not an unfair thing to say.
Matt's has been talking about this for like a year and a half, 2 years now, where he's been saying, now that we've got 3.0 out the door, we're going to focus on tooling. We're going to focus on developer experience. The sell for Ruby has always been developer happiness. Yeah. It's never been like, this is the most efficient systems language. They've never said that. It's always been like bringing developers joy, and other languages are doing it better in some ways. So we need to catch up. Yeah.
There is another project that is Shopify, and I know that you are not all of Shopify, but I'm sure you have some knowledge of it, that I'm pretty excited for on the tooling front, and that's the LSP coming out from Shopify. Do you know enough about that to even comment?
Yeah, it's a great project. They discovered that they wanted to provide the kind of tooling that other languages provide in the IDE. So when VS Code first came up from Microsoft, they decided to invent this technology called the Language Server Protocol. Previously, IDEs had all published their own esoteric custom plugin system. You had to learn whatever it was for that IDE plugin system in order to publish your own language's stuff. And every single language had its own stuff. And there were some standards. There were some XML files you could use, like TextMate and Sublime used the same one. I think Atom used this, like a similar thing. But at the end of the day, you wanted to provide more rich experiences. And so what they would do is they made it so that you could set up any kind of JSON server running in the background, running in any language. And as long as it responds to standard in and standard out using a specified protocol, which is basically HTTP. I mean, it's basically a JSON request. And if you look at the source for any of the language servers, it looks like a server, like a normal JSON server. It has headers, it has content length, like all that kind of stuff. They developed this protocol such that people creating new plugins for IDEs could just conform to this standard, and then any IDE in the world could talk to these servers. So Shopify saw this and saw that the type system had implemented one because Microsoft was in charge of TypeScript, and so they had built it a really nice integration. You get red squiggles, you get nice pop-ups, you get little like question marks, you get all this kind of great stuff. So Shopify decided it was time to invest in this kind of tooling for Ruby, because the existing one, it did work, and there are tools out there. So there's something like SolarGraph that does a similar thing, which is actually kind of an amazing project, like a lot of different pieces to it.
Yeah. And when it works, it is so awesome. When it works is the problem. When it's working, beautiful, amazing. I love this thing. And when it doesn't work, I'm just mad.
The other thing is Shopify has the capital, both in terms of money and people, to really make this happen. So they're putting together a language server. They've been working on it for maybe like a year now, and it's really amazing. So they've been providing all the different kinds of features. So you can hit a certain button to look for document symbols. A symbol is like a method definition or a class definition, and you can jump straight to those things. If you hover over like a local variable, it'll hover over all of the references to that local variable. If you want to fold on the left-hand side, if you want to fold your method definitions, class definitions, blocks, anything like that, it'll do all that. If you have sorbet enabled, it'll do jump to definition. So you can click on a method and it'll jump to that file where the method is defined. You can do like all kinds of inline documentation. Like there's myriad different uses of this thing, and they're really investing a lot in it. So yeah, I know a lot about it because the parser in the technology that you're using underneath it is syntax tree.
Wonderful. You know a lot about syntax tree.
So they're using syntax tree, which is a layer on top of Ripper, which is effectively a event-based version of the current C-Ruby parser. And so they're using all of this different technology, syntax tree at the top, to then go and access the parsed tree, which they can keep cached in the background of the server, to then go and do whatever it is that they want to do.
Now, the parser that you're going to be writing is not a replacement for Ripper. It would be something that Ripper would use.
So the way that the parser works today is it is a generated parser. It uses a parser generator, which is to say that it has a whole bunch of code that does all the lexing. It transforms your input into a bunch of tokens. So if you have def foo equals bar, you're going to get a def token, which is a keyword, a space token, foo, which is an identifier, space, equals, which is an operator, space, bar, which is a method call. So it's like you're going to get, well, it's like, it'll be considered an identifier at that point.
Okay.
So you're going to get this like stream of tokens, and that's all handwritten in C. I can reuse a lot of that, which is great. Then comes in the existing parser a whole bunch of pseudocode. And the pseudocode, it's in the YAC format or EBNF format. And that is just a bunch of pseudocode that is in a .y file. This is like historical. This has like been happening since the 70s. There's another program called Bison that goes and parses that file and then generates another C file that is the actual parser.
Okay.
So basically, it's a way of saying, because they found that generating parsers, you could do it with some jump tables. It was like a pretty common thing to generate parsers. They found a way to just do it with pseudocode. Basically, all that is to say. So they generate another C file that is a parser. Now, Ripper is a wild library. What Ripper uses the same grammar file. So it's the same .y file, except it does something slightly different. So .y files, grammar files, the way that they're structured is they have something called a rule production, which in our example, def foo equals bar. It's going to say, this is a method definition, and a method definition is comprised of the def keyword, an identifier, an equal sign, and then a body. And so like that's like the pseudocode that goes into generating the parser. And what you do is you define an action for that production. And the action is what you're going to do with those tokens. So in our case, we're going to build up a syntax tree. But you could do whatever it else is that you wanted to do. So you have the pseudocode, and then you have a block of stuff that you do in response to it. Subscription, publication. You have an action, and then you do something with it. So what Ripper does is it uses the same grammar, but it changes the actions. And so the actions instead dispatch or basically call a method. It's an event-based or like SAX style. All of this is to say, it's like you define methods like on def, and then you're going to get all of the tokens that were part of that production, and then you do whatever it is that you want to do. Okay. So it changes it from being a top-down, I'm going to build you a syntax tree. It changes it to being like, I'm just going to fire a bunch of method calls, and you do whatever you want.
Huh.
Wild. It's wild. It is wild. It's very interesting. It started around Ruby 1.6, I want to say, by Minoru Aoki, who is a pretty amazing hacker. He's been around for a while in the ecosystem, and he's been doing a little bit less now. I think he has kids and a life. But he wrote a book that is 100% worth reading called The Ruby Hacking Guide, and you can find it online for free. It is brilliant, and it's completely out of date, but it's still got some relevant information in it, and it's worth just watching the madness because it's kind of amazing. Anyway, all this is to say, he came up with this idea of using the same grammar file, and he forked it, just like grabbed it out of the repository and like built Ripper. And it was a separate project until Ruby 1.9 when YARP came in, they changed from a tree-based interpreter to a bytecode interpreter, a whole bunch of stuff changed, and they decided to merge Ripper into the standard library. So now it's a part of the standard library. So going back to the original topic, this is like an add-on that is specific to Bison that is like using this kind of grammar to build this like event-based dispatch thing. And I don't know, there are a lot of useful programs that are built on top of Ripper. I don't want to just like deprecate it. Like that feels not great, but at the same time, I don't know the best way to fix that.
Yeah.
It's not going to be the same structure. I'm not building that same style. I'm going to have different events, different nodes. It's going to look different. So what I was thinking is that I could build the new parser, build the AST entirely, like you have the whole tree, and then like walk the tree and still dispatch those same events, which would be much less efficient. Because the current version, it just fires stuff as it's parsing. Yeah. This would be like parse the whole file, build the tree, do the stuff, and then go and like fire all those events. But maybe that's a good stopgap until people can migrate to the new parser.
Yeah, because like you said, if there's really cool projects on Ripper, you can't just be like, well, sorry, you don't get it anymore.
There are only a couple that I know of that are like really built on Ripper. The rest could be migrated pretty easily. Like there are some projects that use Ripper to parse like a couple statements. Haml, the Haml template language, it uses Ripper to parse hashes, multi-line attributes for HTML tags. That could be easily ported to the parser, like super simple. Yeah. It's not doing the entire like whole shebang, but Syntax Tree uses Ripper extensively. That is how Syntax Tree is built. Fortunately, I'm the author of it, so I will update it to the new parser like day one. So that will not be a problem. The other one is Ruby Format, which was built, well, recently it's been built at Stripe by Fable, and it uses Ripper extensively. It actually embeds a version of Ruby. It's straight up vendors Ruby and uses Rust to call into Ripper and like does a whole bunch of stuff and like serializes it to Rust. And there's like all the stuff that happens after that. And like, I feel badly just like yanking the rug out from under them, being like, no more Ripper. So like, yeah, we'll definitely have to work on that. But for now, Ruby 3.2 is going to come out. Ripper will be there. It's going to be quite a while before this new parser is there. I might just be worrying about something that like isn't actually a problem because it's going to be quite a while.
Oh, it's software engineering. estimating is just don't even bother. But for the sake of the conversation, what do you think as far as before we can reasonably start to say, here's what it looks like, here's how to interact with it?
Yeah, there's a couple of milestones in my head. One is this parses Ruby correctly, which I think is the first milestone. And that's like, I don't want to promise anything, but I think next summer, that's like the plan. That's the plan, is like this parses Ruby correctly.
Is that because you had to POC it to kind of get Matt's and the team on board to kind of like, yeah, this is the prototype, proof of concept?
It's funny. I have a call with them on Monday to show them the prototype so far. So like that deadline could be pushed much further out depending on what they say, if they like what I have so far. So I think I can get it there by then. That being said, like there's tons of unknowns. I know this is a multi-year project, but I think like V0 is like alpha is like probably sometime next year. And then after that, there's like a whole bunch of other milestones. So like getting a fork of Ruby that is actually using this parser. Well, first of all, getting a fork of Ruby that's even building the parser. So like messing with the build system to actually build the dang thing. So that's like a whole nother thing. After that is making it so that CRuby will like publish this artifact, then actually CRuby actually using the parser, then actually replacing the current parser. I think there'd be two parsers for a while, like the current actual one and then this other one. And obviously we're going to want to run both for quite a while to make sure that nothing ever diverges and they're the same. Also make sure that core members feel really comfortable updating it and like really sure how to add new features to it.
Right.
And then yeah, I mean, eventually it will become the new parser. I mean, Mats has said this. He's interested in that. But I think it'll be quite a while. I mean, Ruby 3.2 is coming out in Christmas. I think if they do a 3.4, it would be reasonable to expect that, which would be Christmas 2024.
Yeah. So 3, 4, and 24. All right.
Yeah. If it's 4.0, then it would be that. But I think we could do that. I am also known for ambitious timelines that don't pan out.
Aren't we all?
So we'll see what that actually means. And then the milestone after that, after CRuby is comfortable, they feel good, is spreading it out to the ecosystem. Truffle Ruby adopting it, Shea Ruby adopting it, the parser gem potentially adding a new backend that can use this thing. Other projects like Sorbet adopting it, and mRuby. Matt has talked about replacing the mRuby parser with it. And then Artichoke embeds mRuby's parser. So then Artichoke using it.
And there's even more, right? Natalie is a C++
Yes. Tim Morgan. Yeah. He actually wrote his own C++ parser by hand. So I actually don't think he should use our parser because his parser is great.
Sounds like you got to get him to help with this parser.
I'm working on it. I'm working on him. Oh, for sure.
Okay, cool.
If you're listening, come work with me.
Wow. So you are a busy man with a lot going on for the next 2 years.
Or more years. Yeah.
Or more. Yeah. The next 2 or more for the foreseeable future.
Once this thing gets merged, it's not like I'm going away. I'm locked in for life at that moment.
Yeah. So how do you manage your time? I guess to a degree, it's your 9 to 5.
Yeah. Shopify is paying me to do this.
Thank you, Shopify.
Yes. I'm exceedingly grateful to Shopify and my manager, Ufuk, who is lovely, who is incredibly kind about deadlines and trying to keep the pressure off. Because, I mean, to answer your question, how do I manage it? It's incredibly intimidating. It's incredibly anxiety inducing, like thinking about a massive undertaking like this. And to think about the to-do list is crushing. I don't think about the to-do list. It is a manner of like, just keep swimming. Because if we're being totally honest, it's terrifying. It really is. I think other people would be maybe better at handling this that don't have as much anxiety as I do. But like, if I make the whole to-do list of like every piece of the parser and every piece of it where I want it to go, then I stop in my tracks and I stop working. I really can't. I have to look at only the next piece. But it's such a huge project. It's quite scary. And I don't want to get it wrong. And this is one of the reasons why it's closed source right now. It's going to be open source probably pretty soon, to be honest. But it's been closed source because I don't want it showing up on Hacker News. I don't want anyone seeing this shit. I don't want anyone seeing this until I feel like it is something to show. I'm excited to accept contributors and like make it public and like have everyone see it and everything. But not until I get a little further.
Yeah, that makes sense.
We just got real. This is the real segment of the podcast.
Oh, it's good. This is the podcast to talk about that kind of stuff because That is not a topic I have ever shied away from on here, because
Yeah.
I think that's something, especially juniors coming in, they start freaking out the moment they get their anxiety or they start feeling hardcore imposter syndrome. They're like, oh, I'm the only one that deals with it. It's like, no, everybody deals with it. We all deal with it. And even Kevin Newton deals with it. Like,
but, oh man, it's weird to me to hear you say even Kevin Newton, because to me, I feel like the most junior developer.
That is all of our imposter syndromes, right? I mean,
yes. It never goes away, friends. It never goes away. I'm so sorry to tell you.
But you have a good support system. Work gives you the mental health benefits. You have an incredible manager. Ufuk is one of the most amazing human beings I've ever had the pleasure of interacting with.
I also just have access to the Shopify Slack. Honestly, that's worth it in and of itself. I have access to Aaron. I have access to Maxime, Alan. Yeah. I have really smart people that I can talk to whenever I have a problem. Like, I'm basically never fully blocked. I'll be blocked for myself. I will have problems, but then I will just go talk to my coworkers who are much smarter than me, and they can lead me in the right direction, which is really nice.
Yeah. So key takeaway is a good support system, people to talk to, get a community.
And just try not to panic.
Oh, yeah. Well, easy for you to say. Well, I mean, I panicked even like the first time you and I paired. I wanted to work on syntax tree with you, and you had posted on Twitter like, hey, if anybody wants to work on this, hit me up and I'll pair with you. And I was like, well, no excuse now. And we paired, and I was so intimidated because, number one, that's an amazing project and insane. And I had never touched pattern matching before. And there was just like, I was coming in, do I even bother? Do I have enough knowledge? I was like, well, I hope he'll tell me if I do. And then you were just so nice and gracious and like walked me through everything. And it was a blast. It was so much fun.
It was fun. That was a lot of fun. I had a great time.
It was great. And that's what really was like, you are a very intelligent person, but you are also very good at breaking down very complex topics into something much more simple to understand, which I think is part of the intelligence factor, but then so nice about it. And that's why I'm like, man, how do you manage all of this? Because you're very gracious with your time. You're doing a ton of stuff for the community in addition to this amazingly big project that's going to change a lot about Ruby. It extends past the 9 to 5.
Well, I will say this, part of my anxiety, and this has happened for me forever, is that if I have a big project, I'm very good at getting other projects done. So in college, every semester, I always had my one bad class. And it was like every other class, I would get shining reports, because whenever I had a project for that class, I would work on all my other stuff I had to do. I got to tell you, my house is impeccably clean right now. And I'm doing all these side projects because if I have tons of anxiety about one project, my stress reducer is to work on other things that excite me.
I don't mean to alarm you, but you might have ADHD.
Oh yeah, I know. I get like super hyper focused, 8 hours straight of like doing one project. Yeah, we've talked about this. Yeah. Part of it is also reassurance. So I will say this for junior developers, anyone listening, find something that excites you, find something that you are good at and you want to understand better. Work on it so that you do understand it better, and then it can become the thing that you do to relieve your stress. What I mean by that is syntax tree for me, like working on that is stress relief, because I understand it exceedingly well because I wrote the dang thing and I've been working on it for years. So it is useful to the community. I can somewhat justify it during work hours, though not really. But if there is something that I can do to unblock another team, the Ruby LSP team, when I'm working on a syntax tree, then I will use that time strategically by saying like, okay, I have hit a wall with the parser. Let me go work on this other thing. And you get a validation from it because you accomplish something and you feel good about it. And you feel good about yourself because you're like, I'm smart. I'm a programmer. And you're like, yes, I accomplished this. And that makes it so much easier to go back and work on the hard stuff because you've just gotten all that validation.
Right.
So these are like anxiety reducing tips.
We got some good pro tips here. 2 high anxiety individuals talking about the ways that they relieve stress. I have so many projects going on at work, and it sounds really daunting when I'm describing it to my manager, but she gets it at this point where she just knows I need to be able to, I'm blocked on this thing or I'm stressed out about this thing. So here's another project that I can go work on. I'm fortunate where I don't really have hard deadlines for a lot of my stuff. So I have that ability. When I do have a deadline, there's a little bit more management of the projects that need to go into it, but I hear what you're saying. I feel it in my soul.
Yeah. And the thing is, everyone is going to work differently. Everyone's going to have their own process. And I think especially as you get more senior, your process will become maybe slightly more defined and people will start to understand you a little bit better because you've been around for a while. You've created some things. People know how you operate. And a good manager, like the manager that I have, will take advantage of that to get the best work out of you. Find the way that you work best and then provide the venue for you to do that. So yeah, I've gotten really lucky with managers as well who have like understood implicitly without me having to say like, hey, this is the way I work best. And they've never like had an issue with that, which has been like really wonderful.
But if you don't have a manager that understands it implicitly, anyone listening, don't shy away from telling your manager like, hey, this is what I need to succeed, or I'd like to even try this. I've talked to my manager a few times about saying, hey, I'd really like to experiment with this because I'm not a morning person. I want to start later. And we've experimented with it. And if it works, great, we keep it. If it doesn't work, cool, we go back to the drawing board and we discuss it. I mean, it can be a high stress job. We're doing a lot of thinking about complex topics. There's a lot going on, especially as you get more senior. Nothing gets taken off your plate. More things get added. So being able to find your workflows and work through that stuff is insanely important.
Yeah. The real takeaway for me is like programming is not the challenge at the higher levels. It's not. You do complex stuff, but at the end of the day, you get it done and you'll figure out a way to do it. The difficulty is communication. If you want to progress in your career, don't spend the time exclusively working on your programming skills. Work on your communication skills. Write things down. Write documentation. Write good issues. Write good comments. Write reviews of people in their code. Communication is everything. It's so much more valuable than good code. I would so much rather work with a good communicator than a good programmer because I can teach you how to program.
Learn to break down complex topics into simple ones is a great one, which you're sort of doing with your new blog series. You have the advent of YARV coming out,
And
YARV is yet another Ruby virtual machine. So there's just no M.
There's just no.
Before we dive into that, I got to ask, because there's YARV, which is yet another, YAML, which is yet another markdown language or markup language. And then there was Yak, which was yet another compiler. What is with the yet another?
I don't know.
Where did that come from?
I don't know.
Good. All right,
I don't know.
I feel
YJIT is, well, it's two things. It's either YARVJIT or it's yet another RubyJIT. Yeah, actually, I've named my parser yet another Ruby parser.
Oh, amazing.
Mostly because I think that might be the secret way to get things merged into core.
We're getting into the closed door topics now. If you want something merged, just name it yet another and it will get in there.
Yeah, so I don't know where that came from. Yeah,
you don't know, but it works. So your advent of YARV is a blog series that day one came out. Well, okay, so I don't know when this episode's going to go out, but today is December 1st.
Yes, day one came out today. I have a backlog so far. I have the first 5 ready, which is good. Okay, advent of YARV. YARV is the virtual machine that CRuby uses. It is a bytecode interpreter. That is to say that everything is broken down into individual instructions. Those instructions do things to the virtual machine. The virtual machine you can consider like a state machine, and the state machine has certain things that it's doing. It has a stack of values. So the way that 2 integers get added is you're going to have 3 instructions. The first instruction is going to push the receiver onto the stack. Let's say 2 plus 3. The receiver is going to be 2. This gets into the fact that in Ruby, if you have the plus operator, it's a method call. It's calling the plus method on 2. Okay, so it's going to push 2 onto the stack, and now you've got a stack, and 2 is on it. And then it's going to push 3 onto the stack, and now 3 is over top. And then it's going to pop. It's going to see the fact that it's a method call. It's going to call the opt plus instruction. The opt plus instruction says, okay, I have an argc, argument count of 1. And so I'm going to pop 1 plus the number of arguments, because the other one is the receiver. Okay, so now I've got these 2 values, and I'm going to call the method ID, MID, on the receiver with the arguments provided. So it's going to call plus on the 2 with the 3. So 3 instructions: push object, put object, opt plus. Okay, so this bytecode interpreter runs, and this is like how YARV works internally. There is some documentation, not much. It's all in Japanese. If you look at yarvarch.md or .rdoc or something in the doc directory of Ruby, you see the phrase "maybe writing" period. And that's like the entirety of the documentation of YARP. There's other documentation in the source, but it's relatively minimal. So Shopify once a quarter-ish hosts a Hack Days, which is where you can spend 3 days working on a project that is related to Shopify or not, and it's like meant to inspire and such. And I got a bunch of coworkers together and we worked on documenting every instruction. There is a website you can go to, kddnewton.com/YARV, and you will see, it's a GitHub Pages thing, and you will see documentation for every instruction out there. So that website exists, but even that wasn't as approachable as I wanted it to be. It still uses terminology like stack, frame, call data, or even like a virtual machine, instruction sequence, like all of these things that maybe you've heard of them, maybe you haven't. If you have heard of them, maybe you don't have a good definition of it. So I wanted to really illuminate this because understanding how YARV works and how the bytecode interpreter works gives you a ton of insight into Ruby and how it works internally. And it also gives you the opportunity to potentially contribute in the future. So I think Rubyists are thirsty for information about how Ruby works under the hood. Yeah. And there's just not a lot of content out there. Like the best we have in the community, in my opinion, is the Ruby Under the Microscope book, which is many, many years since it's been published. Like it's been a long time. And there's a lot of stuff that's changed. And it's still the best we have. So trying to fix that a little bit with this blog series of like, this is the way the virtual machine works under the hood. The first post went through 5 instructions and 2 specializations. They're the simplest instructions in the instruction set. The very first one is put nil, which pushes nil onto the stack. That's the entire instruction. So like we're starting off as like simple as we possibly can with what the instructions do. And then eventually we'll work our way up to the more complex stuff toward the end. So yeah, all of that is to say like tons of stuff in YARV that's like not very well understood. I really want to make it well understood. And part of this is an effort just to really inspire the community and to get people excited about Ruby internals.
That is awesome because I know a lot of what you're saying I'm becoming more familiar with because of just, like you said, as a Rubyist, I want to know how it works under the hood. I've watched like Aaron's hack stream on Fridays, which is a lot of lower level stuff. I've tinkered with things, but like I didn't go to college for computer science, but I got into it in high school. So I have an advantage over a lot of other people who got into this career via a boot camp where you don't get a lot of that low level stuff.
I will also say this. I did go to school for this. I went to college for a computer science degree. I never learned any of this.
Okay.
So don't feel like you need a degree for this because I didn't get any of it.
But you get varying degrees of lower level stuff and maybe specializations. But I feel like at the very minimum, it's fair to say that most boot camp grads are not going to understand how this stuff works under the hood. So having a blog series for anybody who is interested in at least starting to wrap their head around it is so awesome.
Yeah, because like the thing is like this stuff isn't that hard. I say that very cautiously because in general, I don't want to say like this isn't hard because that's kind of gatekeepy. But the truth is this part of it isn't. There's a lot of pieces that are hard, but just the bytecode interpreter, the function of it is to not be difficult because you want the computer doing as little work as possible in order to make it more efficient. So like this piece of it should be simple and it should be understood by folks.
Right. But it's sort of like what you said, we're not familiar. It's the terminology. I'm pushing onto a stack. What the hell does that mean? Like once you understand what these terms mean, you're just removing instructions from the stack to execute. It is easy, but that familiarity, the understanding what this word means or what that word means that's the part that I think having a blog post will.
And the thing is, if you go to some websites like the Big Orange website, they will use terminology and jargon to signal that they're part of the in club. They will use it to indicate that they're more senior than you, and they will use it to make you feel bad. So jargon is employed divisively. People do this for job security and their own validation. So to me, the mark of a truly great programmer is when they're not using jargon. So when you see this stuff all over the place, it's not necessarily the fault of the more senior programmers. They have kind of the issue where they've been in it for so long that it's hard to recognize when you are using jargon. But you have to be constantly thinking about that because like if you're using words unnecessarily, or using words that are overly complicated unnecessarily, it just makes it that much harder for other people to be brought in and raised up. So the first thing I did on the part 0 first blog post I did, which is just like introducing the whole post, is I put a glossary, all the terms I could think of that would be relevant. Because at the end of the day, these aren't like that difficult concepts, but like we use this jargon like poorly, and I'm so sick of it. If you come up with a word that you see in my blog series that you want in the glossary, please tell me, or just open a PR, because I will merge the heck out of that.
Okay. Yeah. Challenge for all the listeners, read it. Yeah. And if there's anything you don't immediately understand, reach out, and let's make it something that every Rubyist has in their toolbox to just understand what these things are.
If we could build up the whole community and we could teach everyone all of these concepts, can you imagine the things we could build if we all had this good collective understanding? We could reach amazing heights if we had everyone in the community, like all this information was accessible. I just think it could be a really beautiful thing to have everyone's understanding elevated.
Oh, yeah. Knowledge being accessible is going to do nothing but give us infinitely better things in our community, tools and everything. Yeah. So for now, with everything you have going on, you must have some pretty cool blockers. And by cool, I mean horrible, beat your head against the desks, but interesting to talk about. What do you got going on that's blocking you?
The first one I will talk about is in order to properly parse Ruby code. So, okay, let's back up. Languages have a hierarchy of complexity. The simplest languages in the world can be easily understood by very simple machines. The more complicated your language is and your grammar that describes your language is, the more complex the machine is that you have to use to understand it. This hierarchy was developed by Noam Chomsky, actually, the international relations guy, politics guy, kind of a Renaissance man. So the hierarchy of languages, the term regular expression is used to describe a machine that can understand regular languages. Regular languages are described by a certain complexity, and they can be modeled using something called deterministic finite automata, which is to say a state machine, something that moves in and out of different states with different transitions. So when you see regular expressions, that's what the regular means, the regular language. There are languages that are more complex than that have hierarchy. If you need to parse matching parentheses, a regular expression can't do that. Now, I say that, of course, there are extensions to regular expressions that make it more complex, but the base academic definition of regular expressions cannot parse that. You have to keep a stack. You have to say, if you have open parentheses, okay, you're going to it's something called a push-down automata, which is just to say state associated with the state machine, like more state, a stack, if you will. It's going to push the open parentheses, push, when you hit, and then close parentheses, pop, until you have an empty stack at the end of the thing. Anyway, all that is to say, there's varying degrees of complexities of languages. The Ruby language is very complex.
Yes.
It's very complex. And to get it right is very hard. There's a lot of things you have to know and a lot of state that you have to keep around at any given time in order to get it right. You have to know things at all times. It's less pure or academic or context-free in that case. Context-free is an academic word for one of those hierarchies of languages. Ruby is one level above that, which is a context-sensitive language. I might be getting these flipped, but I think I got it right. A context-sensitive language. That means it has all this context that it has to store in order to parse correctly. You have to keep all this information around. The interesting thing is, this is a quick aside, is that the parser generators are used to parse context-free languages. So you have to hack around the parser generators a little bit to get it to do higher level stuff, which is why you see a ton of state stored in the lexer in Ruby. That's not important. Let's go back to the actual question at hand. So what are my blockers? Getting this right, parsing it correctly, parsing it the same way that CRuby currently parses it is very difficult because you have to think about where your state is going to live. When I say state, I mean things like how many parentheses deep am I? That's one. I'm talking about, am I inside of a class? Am I inside of a module? Am I inside of a def? When I say inside, I mean literally in your file within the bounds of the class keyword and the end keyword. So thinking about that state and building up the stack of various things, there's magic comments at the top of the file, like frozen string literal. One of those magic comments is encoding, and that drastically impacts the rest of the file. Parsing identifiers is encoding dependent. So if you have identifier encoding ASCII at the top, and then you put emojis in your code, what do? So matching that behavior is very difficult. So that in and of itself is my top level blocker. It's just the sheer complexity of the Ruby language and making sure I get it all right. It's not the different pieces of syntax. Like I can add different pieces of syntax all day. That's not the issue. It's like the complexity of how those pieces interact that makes it difficult. So yeah, that's like the first main thing. As an example of the complexity of the Ruby language, do you know Trick, the TRICC? I don't exactly know how to describe it. It's like this really interesting project thing, competition that happens once a year. That's like,
at RubyCoggy?
Yeah.
Yeah. It's just essentially code art and code golf that actually functions.
Here we go. The Transcendental Ruby Imbroglio Contest.
It's wild. I'm going to include it in the show notes for anyone interested. So all the files, when you open them up, it's like a pretty picture. It's like an ASCII art almost. Is the source code, but the source code runs.
Yes.
And it does something cool. And it is mind-blowingly crazy.
It's beautiful. It is our industry's art. Yeah.
Yeah. The first program is the Trick intro. And it's like fire in your terminal and then print so pretty. But if you open it up, the source code is in the shape of a Ruby gem. It's art that produces art.
Yeah. It's multidimensional. One of the entries for this year was a fascinating one. You can put in the show notes. It's entry 04-tompng. So entry 4. And that entry involves displaying the fact that the Ruby parser only functions correctly if it knows every local variable in any given scope. You have to know which variables are local variables and which are method calls. You have to know that information because there is some ambiguity in the grammar between forward slashes. Forward slashes can be a division operator, or the start of a regex. Now, if you have an identifier and then a forward slash, the question is it a division operator where the identifier is a local variable, or is it a method call where the regex is an argument because parentheses are optional?
Right.
Turns out it's a division operator if the identifier is a local variable. Otherwise, it becomes a method call.
Whoa.
You can use this for your game show.
Yeah, I actually have a pretty good one, spoiler alert, where I didn't realize that the equal squiggly, the match, will automatically take named groups and create local variables for them.
Yep. This is the point of what I'm exactly about to tell you. Okay. You have to know all of the local variables in any scope in order to parse Ruby correctly. Okay, so what does that mean? It's fine. I can find all the local variable assignments, but there are things that introduce local variables that are not local variable assignments. Two things. One, things in pattern matching that map into an identifier. So that's fine. That like I can parse that correctly. That's like just part of the grammar. The other piece is regex capture, named capture groups. Those create local variables. Now, here's my issue. Regular expressions are parsed using the Enigma library that CRuby vendors as part of CRuby development. It is a separate C library. The entire point of this project is to not require you to go and do that. So I need a regular expression parser.
Oh my gosh. Oh my God.
That's the reaction I was looking for. Yes. So in order to properly parse Ruby, you need to know all the local variables. In order to know all the local variables, you need to parse regex, which means now I need to go and build a regex parser. So it's like, talk about blockers. I realized that like a month into this project, I'm like, oh my God, come on.
Wow. Oh man. Yeah, you need to create a regex parser to write your Ruby parser was not the blocker I was expecting when you were like, yeah, the parser is hard. I'm like, yeah, Ruby syntax is wild. I did a whole talk on it. Like, no,
it just goes, it just keeps going down. Yeah, it's ridiculous.
Oh my gosh.
There's other blockers like herodocs are just like difficult to parse.
Yeah.
You find the open tag, the declaration, whatever we say, like the beginning of the thing, the less than sign. And then you have to decide where's the new line. You need to skip to the next new line. You need to go ahead and parse all the content. Then you need to go back and continue to parse the rest of that line. Or you can like push it onto a stack, finish parsing the line, and then pop off the stack and then go back and add your content. There's like a couple ways you can do it, but it's not easy. So there's that. There's like all these different kinds of lex states you can be. When I say lex, let me break that down. Lex means lexical analysis. Lexing is the process of breaking a string of source code that's just text into individual components. Identifier, operator, equals, like whatever. So lexing is just very difficult because you have to have a certain amount of state, because if I see an identifier, it matters if I'm inside a string or if I'm not. So you have to have that like some amount of state around. If I'm just like parsing like a calculator, you don't have to have any state. Lexing is very simple. If I find a number, it's a number. If I find an operator, it's an operator. Lexing doesn't get more complicated until you have like different states. And we unfortunately in Ruby have quite a complex grammar with a lot of states.
Yeah, it's what makes Ruby wonderful and weird and incredibly difficult to write a parser for, it turns out.
So in terms of blockers, yeah, it's really the complexity of the language. It's things like the regex thing. I just figured out the encoding thing. I'm embedding. There's like a UTF-8 decoder that I just wrote that like embeds into this thing, which turns out to be actually not nearly as bad as I thought it would be. It was like 30 lines. I was like freaking out about it. And then it was like 30 lines of code. I was like, oh whoops, that was way easier than I thought it would be. But yeah, I mean, there's just tons of complexity to do with the grammar. So the other massive goal of this project is error tolerance, being able to recover from syntax errors. This is my biggest blocker.
Because you want your red squiggles.
I want my dang red squiggles. That's exactly right. So error tolerance is not a well-researched topic. There are papers. There are things you can read. It's not like a big field. There are tens of us. There's like not many folks that are starting this. Fortunately, I do have access through Shopify to some of these academics that are doing work on this. So I have talked to people. Lori Tratt in particular has done like amazing work on it. But there's a lot of different approaches. And I don't think really, there's not like an industry standard that's like, this is how you write an error tolerant parser. There's a lot of different approaches and a lot of different ways that are being evaluated. The current one I'm running with is actually kind of interesting. All of this only occurs if you have a syntax error, like only. Writing the actual parser is one thing, and then this entire other half of the project that occurs when there's a syntax error. So it's like the current Ruby parser like does some things, and actually 3.2 is going to come with a little bit more error tolerance because of the way that they changed the end keyword. But it really doesn't have this like overall holistic baked in thing. The current approach that I'm running with is like if you have a syntax error and you have some token and you don't know what to do with it, let's say it's like the end keyword. You have an extra end and you're like, oh shit, what do I do? So if it could be interpreted in multiple contexts, it could be an end to a block or it could be an end to a class. Then we actually fork and go down both paths and say 250 tokens past this token. How many errors do I have? Because the reality is if you have one syntax error, you're likely to have more. But let's say that this end token could be closing out a class definition or it could be closing out a module definition. The module is like a parent of the class. If it actually does close out the module, you're going to end up with no more syntax errors. Because if you just close out the module and parse the rest of the file, then you're good. But if you close out the class, then you've got this like dangling module up top and you're going to end up with all this other stuff. So it turns out to be a pretty good approach, but it means that you have to write two paths through the parser. One that actually builds the EST as it's going, and another one that is just this heuristic, how are we doing in terms of number of errors?
Right.
And you don't want to allocate anything. You want that to be as fast as possible. So,
wow.
Yeah, error tolerance is like the biggest thing. It's what I'm reading papers about. Actually, I've kind of paused work on the parser for the last like 2-3 weeks, even just reading about this stuff, like trying to come up with like the best approach going forward. And this is one of the reasons why like the parser is just such a multi-year project, because I think I got honest to God spend my entire career on this.
Well, some people do, right?
Yeah, it's more art than science even, because like you want your error messages. Like one of the issues is a bad error message is actually worse than no error message. If I just say unexpected end, Rubyists have kind of gotten better at like fixing that. But if I say unexpected end, we think it belongs to this and I'm wrong. Oh God, I'm sending junior developers down rabbit holes that they're never going to be able to get out of. And it's like, oh my God, I've actually caused more issues by providing a bad error message. So it's like, this is such a balancing act.
Yeah. Anytime there's something goofy where the error message implies that it's something, and then you 3 days later are finally done debugging, you're like, it had nothing to do with that. It's the worst feeling. So yeah, I appreciate you spending the time making it good.
So that's like the greatest fear is we ship this like error tolerant parser and then it's like just sending people down terrible directions. It's like, oh God, what did we do? So getting that right is going to be, and like it's going to be a multi-year, tons of iteration on it. I'm starting off basically as conservative as I possibly can be. I'm only going to recover and say like, okay, I am like really sure this is what was supposed to happen. So interesting blockers to be sure.
Yeah, very interesting, very deep thinky blockers. Not the kind of blockers I deal with writing just a regular web app, that's for sure.
It's just different context. I mean, at the end of the day, if you're writing a web app, you have to be super empathetic to your users and make sure that you're giving them a great experience. My users are developers, so it's just a different context.
That brings us to our final question, which will be a very interesting one to have you answer. What is something cool or interesting or just awesome that you have recently discovered or even written yourself or done that you want to share? And it doesn't have to be coding related.
Yeah, something I've been thinking about for a really long time is writing Ruby in Ruby. Like Rubinius has been around for a long time. It's not really being developed now, or if it is, I'm unaware of it. The purpose of this, in my mind, is not to replace Ruby or to create another Ruby runtime. Like, that's not my goal. I want to use it for education. I want people to understand how Ruby works, and I want people to be able to see the internals written in Ruby because, I mean, it's significantly easier to read. So part of the series, the blog series that I'm doing on Advent of YARP, under every instruction, you're going to see a Ruby translation of that instruction, which is like a class, like putNil, class putNil, and it's going to have a call method, like def call. It's going to accept a VM, which is a virtual machine, and it's going to say vm.stack.push nil. You can go and see that on the first post today. You can get those instruction sequences in Ruby right now with Ruby VM instruction sequence.compile. And that will give you instruction sequence object. You can call 2A on it, and it's going to give you an array of symbols that are all the instructions. So like you can go and access all of this information right now. And it turns out that if you can take all that information and build your own virtual machine, you can emulate Ruby in Ruby. You are iterating through an array. The array has instructions in it. The instructions are symbols. So it's a big case statement. You have a stack. Stack is an array. You're going to see put object, and you're going to get an actual object. So you push that object onto the stack. You can get put object, but you're going to get opt plus. You call pop with 2. You say receiver dot send, splat the arguments. And this was inspired by Ilya Bialich's work, where he did an amazing blog post called Evaluating Ruby in Ruby. And it was 2020, and I read this, and it was just like absolutely mind-boggling. So there's another repository called Ruby Spec, which lives under the Ruby GitHub, and it's just a bunch of specs that all of the language implementations use: Truffle Ruby, JRuby, CRuby. It describes the behavior of various syntax, method calls, whatever. And he actually made it so it actually passes most of the specs.
Wow.
Because it's evaluating Ruby within Ruby. And I find that fascinating. I love it so much. I love it so much because it is an educational piece. It shows you how Ruby works under the hood. It shows you how YARP is running. As part of this blog series, right before the blog series kicked off, I built that into syntax tree. So I added a piece that Ilya doesn't have in his, which is I will take the syntax tree, and I compile it into YARP instruction sequences. Then I go and execute those instruction sequences. All of this happens in pure Ruby. There is a visitor that visits the syntax tree, and then it goes and compiles it using simple arrays, simple classes. It's just pushing objects onto an array. And then it goes and walks through that array using literally the bare Ruby concepts. It's iterating through, and it will go and execute all those things with a stack that is an array. And the function of all of this is not to say, like, this is the future of Ruby. The function of this is to better understand it. I gained a ton of insight into how Ruby worked by building this. And so my dream, my long ranging dream that probably will never happen, is every piece of Ruby written in Ruby and a visualization tool that you could plug in to, I don't know, like a Rails app or something that shows you a visualization of the stack. It shows you a visualization of the frames. It shows you a visualization of the source and the syntax and like how it gets compiled into bytecode, executing the bytecode, throw widget in there and like watch as the bytecode gets transformed into machine code, just like seeing the whole thing as it all fits together, because I learn visually and I want to provide that opportunity for others to learn what I have learned in a more approachable way, because my knowledge has been gleaned more difficultly than I would have liked. So I would like to provide it to people in an easier way.
That is very cool. Writing things in Ruby, not as a replacement, but as a learning tool. This was great. Thank you so much for coming on.
Yeah, thanks for having me. This was really fun.
Thank you for all you do for the community too.